Okay.
Okay, welcome to the final content session, which I'm going to assume that this will be the final session that I offer to the Psych 3704 student, the support that I can give you. We're going to discuss the last part of the decision tree that we had originally when we started. We already covered the statistical hypothesis when we have one variable or one population, two population, when it is independent and dependent. We also then looked at the variable when we do have a numerical variables, two numerical variables, or two categorical variables. So today is the last one where we look at two categorical variables. So we're going to look at how we do hypothesis testing for that. Okay, so by the end of the session today, you need to know, or you should have learned about the basic introduction into the hypothesis testing for two categorical variables, nominal variable for independent variables, and how to make decisions based on the test, that the statistical test and the critical value. So when it comes to two categorical variables, we can do one of the tests. So for numerical variable, we said we use the correlation. For two categorical variable, we also need to test the relationship if it exists between those two categorical variable, or what we call them nominal or ordinal variables, if they are dependent on one another or independent from one another. So similar to the correlation, your chi-square test for independence uses a contingency table. So we are going to use what we call a cross-tabulation table, which will have a number of rows and number of columns to it. So depending on the type of a variable that we have, if it has three values, like for example, a yes, no, maybe response from one of the questions, then it will have three rows. And if we're doing a test of a relationship between gender, then gender has two values, male and female, so it will have two columns, something like that. Even though your chi-square test evaluates the upper tail area, you will see when we do the decision, we are only going to look at the upper tail area, which is one-sided area, but your chi-square test is always a two-tailed non-directional test. So how do we state the null hypothesis and the alternative hypothesis testing statement when we deal with chi-squared? The null hypothesis, which is what the researcher wants to prove, will always say the two categorical variables are independent. Always remember that. It will say the if I do have the two categorical variable, let's say one of them is school preference and the other one is gender, then it will say gender and school preference are independent, or there is no relationship between gender and school preference. And in your alternative hypothesis, you always state that there is a relationship. So you will say the two categorical variables are dependent, or you might say the two categorical variable, gender and school preference are dependent, or you might say that there is a relationship between gender and school preference. So that's how you're going to state your null hypothesis and your alternative hypothesis. The keywords are independent for null hypothesis dependent for the alternative. Because we said we're going to be using a cross tabulation or a contingency table, with the contingency table, you will have your variable 1, which will be your, if we're using data types, so it will be data type 1 and 2, and then your variable 2 will be on the outside where we use category 1 and category 2. Inside is where you will say category 1 and data type 1, they will have their number of amount that they join on. And category 2 and data type 1 will also have number of events that they join on. And you need to also make sure that you add the column total and the row total so that then the sum of it will create what we call a sample space, or your N, or your grand total. So that will end up being your N or your grand total. And then the other thing you also need to be aware of is all the time in the question, they will give you the observed values. So the observed values are the ones that they are giving to you inside the table. Those we call them observed values. Look, A, B, C, and D will be the observed values, and the total will be those values on the outside. In order for us to test for chi-squared, we need to use this formula. And this is the formula to calculate the test statistic, which is the sum of your observed value minus your expected value squared divided by the expected value. So in a way, the formula will write it as the summation, remember, the summation of your observed minus your expected squared divided by your expected. So what does it mean? It means from the observed value, we need to go and calculate the expected value. And we calculate this expected value by using the total, the column total, and the row totals. And then you're going to square the answer from the difference between the observed and the calculated expected. And you square the answer and you divide that by the expected. And you will do the expected for each and every value. And then once you have done that, you will go and sum each value. So you will do your, let's call it the expected value 1. You would have calculated it there. Then you will say A minus E1, and you're going to square that. And then you're going to divide it by E1. And you do the same. So let's say this is B1. So you will say B minus B1 squared divide by B1, and you do for all of them. Then when you are done, you're going to add all the answers. That is what the summation means adding all the answers together to get the value of your test statistic chi-square. Okay, so we're going to look at an example on how we do this. But before that, you also need to be aware of how you're going to make a decision and conclude at the end. So the decision is based on the test statistic that we would have calculated, which is this formula you would have calculated, and the critical value. And the critical value is the value you're going to find on the table. Now, in your module, they are not expecting you to go and find the critical value, but you are expected to know how to make a decision. So in the back of your mind, know that we go somewhere on the chi-square table and we get a value, and we use that value, we compare it to the calculated value, and then we make a decision. How we will make a decision, we'll say the test statistic, if it's greater than the critical value, which is the value on the table. So let's put it this way. This is the calculated value, and this is the table value. So you will say, if the calculated chi-square test statistic is greater than the table value of the critical value, then we're going to reject the null hypothesis. Otherwise, we do not reject. And to find the value of the critical value, we always use your alpha, which is your level of significance, and the degrees of freedom. And your degrees of freedom is calculated by means of the number of rows minus 1 times the number of columns minus 1. So what is it that we're going to be doing? So when we do hypothesis testing for chi-square, the first step is to locate and collect your observed frequency data. That will be the data given to you in a contingency table as part of the statement of what the researcher wants to prove. Then the next step, you need to go and calculate your expected value or your expected frequency. And this expected frequency, we calculate it by using the raw total, not the number, but the total. Remember, the total are those values at the end. So the row, this is the rows, and these are columns. You will need to always remember that. The row total times the column total. So we use the row total times the column total divide by our grand total, which is our n. That's why I said we have to add all those n values and then all the total so that we get the grand total. And that's how you're going to calculate the expected frequency. And you will do this for each and every value, and I will show you how to do that. Then you need to go and determine what the degrees of freedom is. And remember, the degrees of freedom is your row number of rows. So you're going to count the number of rows excluding your totals. So, and the header. So you're going to say, so we're counting only the number of rows of the actual categories that we are calculating, category values that we are calculating. So you'll say number of rows minus 1 times number of columns minus 1. If I have a contingency table with, and this is the total, and this is the total, and I have column 1, column 2, and row 1, and row 2. I've got 1, 2 rows, so I will say we've got 2 minus 1, and I've got 1, 2 columns, and I will say 2 minus 1. And that's how you will do your row total minus your column total. Okay. Once you have calculated your degrees of freedom, then you will need to also go and find your critical value by using also the alpha value. So don't forget, it's the degrees of freedom and the alpha which would have been given to you that will help you to go and find the critical value, which we defined as chi alpha over chi alpha 2. Then we're going to calculate the chi-square test, which we calculated using chi-square stat is given by the sum of your observed minus your expected squared divided by your expected. Remember, that is the formula that we're going to be using. And then once we are done calculating our chi-square test and we have our critical value, then we can go and find the p-value. Sometimes they will give it to you. Always remember that the p-value, if your level of significance alpha is less than your p-value, you will reject the null hypothesis. That is what this decision is saying. If we're going to be given the p-value, then the rule states that if the p-value is less than alpha, we're going to reject the null hypothesis. Between the critical value and the test statistic, the rule says if your chi-squared stat is greater than your chi-square alpha, we reject the null hypothesis. So we've got two ways that we can make a decision, either by the chi-square and the critical value or the p-value. Okay. So let's look at an example. So let's say we've got two questions from a questionnaire that we collated. One of the question was, do you like the television program? And the responses were like or dislike. So you had to tick which one, whether you like or dislike a television program. The next one was asking people, what is your gender? So maybe this was one of the cinemas, and they wanted to find out there's a new release of a movie on TV, and they want to make sure that maybe probably they would take that and use it in their cinema. So they just wanted to know if people watch the television program, or maybe this is DSTV wants to know. So those would have been, out of all the other questions that they were asked, they chose those two because they want to test if there is a relationship between gender and television program, whether people like the TV program. So they also want to see if it appeals to which kind, right? So is there a relationship between the two? So we're going to have to test if there is a relationship between gender and the response to the question, do you like the television program? In order for us to do that, so we collected the information and we put it in the cross tabulation like we did now. On this table, we have our gender as columns and our choice preference of a movie program as rows. And we know how many females liked the TV program. There were 14 of them. 36 male liked the TV program. 30 disliked it, and 25 female disliked the TV program. Overall, 105 people answered or responded to this questionnaire. But out of those, we know that there were 66 male, there were 39 female, or there were people who liked the program, there were 50, and those who disliked the program, there were 55, and that's the contingency table. From this contingency table, we're going to state our null hypothesis. Is there no relationship between gender and choice? Because that's how we state the null hypothesis. We state it by saying no relationship or they are independent. The alternative will state that there is a relationship between gender and choice. Now we can go and find the expected frequencies and assume that the rows and the columns are independent from one another by multiplying the row total by the column total and dividing that by the grand total. So what we mean is, if we're going to calculate the expected value for 36, we're going to take the row total, which is 50, and the column total, which is multiply, because it says multiply by 66, divide by the grand total, which is 105. So what we did is row total times column total divide by n. That's the formula to find the expected values. From that, so I already spoke about those. So we calculate the expected value and we get the expected value to be 31.43. So what we're going to do is we're going to put the expected value in the table that looks similar to this. So we go ahead and we create the expected value table, which looks exactly like our observed values. And from here, we then can calculate our degrees of freedom. Remember, our degrees of freedom was the number of rows. We've got 1, 2 rows. We don't count the total. So we've got 2 rows and 1, 2 columns. And we will say 2 minus 1 times 2 minus 1, which is 1 times 1, which is equals to 1. Therefore, our degrees of freedom is 1. From there, we're going to calculate our test statistic. Remember, our test statistic, which is psi chi-square stat, it's given by your sum of your observed minus your expected squared divide by your expected. So what I do on this table is to take all my observed values. As you remember, my observed values were 36, 14, 30, and 25. And my expected were 31, 18, 34, and 40. So I just put them corresponding to one another next to each other so that then I can say observed minus expected, which is the first one. And I do for all the values to calculate the expected, and then I square the answer and divide it by the expected, and then I get these answers. So now I've calculated all the values there. So I'm going to now add, because this is the summation. So when I add all the values together, so adding all these values, I get 3.42. And that is my chi-square test statistic. My chi-square test statistic. And from here, I can then go and make a decision. So I can go to the table, which is the table, the chi-square table, and go onto the table and find my degrees of freedom. Remember, we did find the degrees of freedom to be equals to 1. And let's assume that our test was at 0.05 level of significance or alpha. So on the critical values of chi, then I go to degrees of freedom on the right, on the left. And at the top, I go look for the alpha value where they both meet. That will be my critical value. So now I've got my critical value and my test statistic that we've calculated. Remember, it was 3.4. I think it was 3.4 or 2 or 4.3, but it was 3.44. And I have my level of significance or my critical value of 3.481, which is the table value, and then I can make a decision. Remember, the rule says if my chi-square test is greater than my critical value, then I am going to, so the rule, let's write the rule again so that we can compare. So my test statistic, which is 3.44, if it's greater than my critical value, which is 3.48, we're going to reject the null hypothesis. So let's look at it. Our chi-square test is 3.4 and our probability or our critical value is 3.8. So our chi-square test is less than our probability value because this is smaller than that. So it means we are not rejecting the null hypothesis. So the decision will be we do not reject the null hypothesis and we conclude that there is no significant relationship between the choice of the movie and the gender. Because the null hypothesis said there is no relationship, so we have proven that there is no significant relationship between the two. And that is it. Any question?
No, so far,
Okay.
this demands a lot of attention, but so far so good.
Okay, cool. Now let's look at activities. I'm gonna give you time to read this and then I'll come back and then we will do it together. Let me see if you can do it on your own first. Read the sentence. Okay. A researcher wants to establish whether the type of employment category is filled by employees of a particular company is significantly related to their gender. The employees can be categorized as manager, human resource administrative maintenance, or information technology worker. The genders are male and female. Which would be the most appropriate test to use? Is it 1, the test for 2 independent samples, 2, Pearson correlation test, 3, chi-square test?
I'll take 3.
It will be 3 because we've got 2 categories. We've got the employment category and also we've got gender. Okay.
Yes. So sorry. Just before you move from the question 1. So what will be our null hypothesis here?
You will say there is no relationship between employment category and gender. Or you will say employment category and gender are independent.
Okay, thank you.
Okay, which one of the following is the appropriate formula for chi-square test? Is it number 1, number 2, or number 3?
It is number 1.
It will be number 1. The first one, it is for 1 sample. The third one is to calculate the coefficient of correlation R. A contingency table represents, I'm going to give you 2 more minutes or 1 minute to look at the answer. Do we have an answer? Is it number 1, the distribution of the frequency of
I think the answer is 3. I'll assume that the network now is affecting you, since you said you will be load shedded at about 12 o'clock.
Hi. Sorry, load shedding happened. I don't know where we left off. Do you hear me? Okay, I hope you are able to hear me. We can just continue from where we left off. Okay, a contingency table represents the distribution of the frequency for a variable, frequency count for each of a number of possible outcomes for an experiment, or 3, then a frequency count of each outcome assumed on a nominal scale variable when are cross-classified. Which option? Is it 1, 2, or 3? And that will be option 3. I've got to challenge myself. I think I don't want to move anymore. Let's see. Number 4. Which one of the following tests are appropriate for determining whether a relationship exists between variables if both are assumed on a nominal scale? Number 1. The test for 2 independent samples, or the t-test for 2 independent samples. Number 2, the test for significance of Pearson correlation. And number 3, the chi-square test. Fortunately, it was load shedding. So which one of the following tests are appropriate for determining whether the relationship between exists between 2 variables if both are measured on a nominal scale of measurement? 1, the t-test for 2 independent. 2, testing the significance of a Pearson correlation coefficient. Or 3, the chi-square test. Which option? You can also, if you can't talk, you can also put it on the chat, unless if I'm not audible.
Yeah, I think 3. I don't know if I'm wrong, but I think 3.
3 will be correct because we're talking about 2 nominal scale. Test for 2 independent samples. This will be the for 2 the before and the the 2 population samples, And then the next one will be for numerical variables. And also remember, that's the other thing. We spoke about this the last time when we were doing the correlation. The important thing is, in the question, if they state relationship, it cannot be for independent. If they are asking for two independent variables, they will say, is there a difference? For this one, they will say, is there a relationship? And for this one, they will say, is there a relationship as well? So it is very key that you understand how to read your statements and your questions very carefully. So when you see, is there a relationship, then you know that it can only apply to those two, Pearson or chi-square. If it's Pearson, then it means you have two numerical values. But if you are talking about categorical values, nominal or ordinal, then you are talking about chi-square test. The chi-square test is used to compare which aspects of the data for the samples, for the two samples. Number one, does it compare the distribution of the data as classified in terms of the variable? Number two, does it compare the sample means of the variables for each sample? Number three, does it compare the sample variance of the variables as measured for each sample? 1, 2, or 3. Think about everything that we discussed today. Did we talk about mean or variance? If we didn't, then it cannot be. Then it cannot be, because if it's chi-square test, you cannot calculate the mean or the variance of a nominal data.
Okay, so that leaves us with one.
That is number one. As long as it talks about classified or classification, that will be number one. A number of psychiatric patients are classified by gender, which is male or female, and into one of four categories: schizophrenic, severely depressed, bipolar, and others. Which of the following is suitable for representing counts of frequencies of persons which falls in each possible subcategory? Number one, is it a contingency table? Number two, is it a scatter plot? Number three, is it a histogram? Number four, is it a spreadsheet? 1, 2, 3, or 4.
So is it right if I take A based on classified by gender, and which will be comparing the two?
Yes, you are correct. Scatter plot, we use it when we compare two numerical values. Histogram, we use it when we look at a distribution of one value. And a spreadsheet is just the tool that we use, the software tool that you use to put the data on. Okay. Number 7, representing the gender of male or female of members of parliament versus their political party to which they belong is the best done in the form of a 1, is it scatter plot? 2, is it contingency table? 3, is it a 2 sample group design? So here we have gender and political party. So political party will be like ANC, DA, KISS Party, ADCP, EFF. So there are categories. So
row and columns.
yes, it will be
I think
option 2.
contingency table. Yes.
Yes, it will be a contingency table. Remember, scatter plot is for two numerical variables. Two sample subgroup design is an ANOVA. You don't even cover that in your module, so you don't even have to worry about that one. And that concludes our session. Are there any questions, comments?
No, that will be all. Just thanks a lot. Thanks a lot, even though we disconnected for those few seconds or minutes, but thank you.
No problem. And this concludes our sessions was. Those who joining us for the first time ever, please understand that we are from Pambili Analytics, a company that cares about your success. We're trying to bridge the gap in data literacy, numeracy, and analytical skills. And we offer this from a range of services that we do. And one of those being our flagship skills training and development, where we offer instructional-led sessions like this one, but we are it's at a cost. So at the moment, we're running a special which ends on the 31st of 150 Rand per hour online. And if you want to gain access to the previous recordings or recordings of the previous years, they are available for free on YouTube. You can watch as many as you watch. You can binge watch, but remember to subscribe, to like our videos, and to share our videos as well. If you are interested in gaining access to the current sessions that we have on a weekly basis, Mondays and Tuesdays, Saturdays and Tuesdays, you can access them only if you become a member of our YouTube channel. And we've got 5 membership types. But the most important memberships that have value are the loyalist, appreciator, and promoters, where you will gain access to the recordings and the notes. Remember also, you will be saving a lot from paying a 350 per hour to having to access all the recordings for 79.99 per month. It's a bargain. So if you want to get hold of us anyway, anyhow, if you want to ask us anything, you can find us on WhatsApp as well as via email. Otherwise, have a blessed weekend. And good luck with your studies, because today is our last session. So I am seeing you, or I'm talking to you for the last time, unless if you want to book a session with us, you are more than welcome to talk to us. And thank you for being part of the sessions. Bye.
Thanks a lot. Thanks for your time and everything. Thank you.